Okay, well, welcome back to our class on algorithms and data structure. We're continuing our progress through some interesting material here. We've talked about bags, bag implementations. We've talked about the efficiency of algorithms. We talked about stacks, queues, recursions. And for this lecture, we're going to be talking about lists. And this will get into several lectures that are related to that. And so this one will be a little bit more of an introduction in terms of what a list is all about here in the context of an ADT. And so what we're showing here, the textbook chapter contents. And so we'll give the specifications for an ADT list. We'll talk about using the ADT list. And then we'll talk about the Java classes that are relevant, the interface list and the class array list. And so a list provides a way to organize data. We can have to-do lists, gift lists, address lists, grocery lists, event list, or a list. These lists provide a useful way to organize our lives as illustrated in figure 10.1. And we're seeing that here. Each list has a first item, a last item, and usually items in between. That is, the items in a list have a position, first, second, and so on. An item's position might be important to you or it might not. When adding an item to your list, you might always add it to the end, or you might insert it between two other items already in the list. List is a collection, and this chapter formalizes it as an ADT. So to specify the ADT list, we describe its data and specify the operations on that data. Unlike common lists whose entries are strings, the ADT list is more general and has entries that are objects of the same type. The following is an initial specification of the ADT, and we'll talk about this in a couple of ways. And so this adds a new entry to the end of the list, add a new position, new entry. This adds a new entry to the list at a given position. Remove given position. This removes the entry at a given position from the list. Clear removes all entries from the list. Replace given position, new entry, replaces the entry at a given position in the list with a given entry. Get entry, given position, retrieves the entry at a given position in the list. And toArray retrieves all entries in the list in their current order and contains an entry, sees whether the list contains a given entry. Get length gets the number of entries in the list, and is empty sees whether the list is empty. So a variety of different things that are spelled out. Well, let's think about this for when you first declare a new list, it is empty and its length is 0. If you add 3 objects, A, B, and C, one at a time in the order given to the end of the list will appear as A, B, and C. So we're seeing that in the top there. The object is A is first at position 1, B is position 2, and C is the last at position 3. To save space here, we will sometimes write a list contents on one line. Some people number the entries in a list beginning with 0 instead of 1. For example, we might write A, B, C to represent this list. The following pseudocode represents the previous 3 additions to the specified list: my list add A, my list add B, my list add C. So at this point, my list is not empty, so my list is empty is false. Since the list contains 3 entries, my list get length is 3. Notice that adding entries to the end of a list does not change the position of entries already in the list. So figure 10.2, as we're showing, illustrates these add operations as well as the operations that we will describe next. So now we can summarize and refine our description of the ADT list in light of our previous discussion. So we had some general introduction to a specification. Now we have some more details, and I'll just leave that there for reference, and you can look it over. So we have it over a couple pages, this information, and so we just talked about those at a top level, so won't rehash going through those tables in detail. So the Java interface in listing 10.1 contains a method for an ADT list and detailed comments that describe their behaviors. These comments refine the specification given the previous segment. The items in the list will be objects of the same class or classes related by inheritance. So this takes several pages, so I'll just quickly go through that. And so you can read over that either in the textbook or see them in the charts at your leisure. Well, let's talk about using the ADT list. Imagine that we hire a programmer to implement the ADT list in Java, given the interface and specification that we have developed so far. If we assume that these specifications are clear enough for the programmer to complete the implementation, we can use the ADT operations in a program without knowing the details of the implementation. That is, we do not need to know how the programmer implements the list to be able to use it. We only need to know what the ADT list does. So this section assumes that we have an implementation for the list and demonstrates how we can use a list in our programs. The examples here can be part of a program that tests your implementation. So as an example, as we're seeing in the figure, imagine that we are organizing a local road race. Our job is to note the order in which the runners finish the race. Since each runner wears a distinct identifying number, we can add each number's number to the end of the list as the runners cross the finish line. And we're seeing this in the figure. So the Java program listing in 10.3 shows how we can perform this task by using the ADT list. It assumes that the class A list implements the Java interface list interface that you saw in the previous section. Since the list interface assumes that the items in the list are objects, we will treat each runner identifying number as a string. The data type of string of display list input parameters lists the interface string. Thus, the argument of the method must be an object that satisfies both of the following condition. The object's class must implement list interface, and the object must be instantiated as a list of strings. Although the method works for any implementation of ADT list, it works only for list of strings. You could remove the latter restriction by revising the header of the method as follows: public static T void display list interface T list. Now the list passes to the method can contain objects of any one class. So we'll have a couple examples here. First, here is a professor wants an alphabetical list of the names of the students who arrived for class today. As each student enters the room, the professor adds a student's name to a list. It is up to the professor to place each name into its correct position in the list so that the names will be in alphabetical order. The ADT list does not choose the order of the entries. The following Java statements place the names Amy, Elias, Elias, Bob, Drew, Aaron, and Carol in an alphabetical list. The comments at the end of each statement shows the list after the statement executes. Here's another example. Let's look at a list of objects that are not strings. Suppose that we have the class name from list B1 in the appendix B that represents a person's first and last names. The following statements indicate how we would make a list of names: Amy Smith, Tina Drexel, and Robert Jones. Now let's treat the name that is the second entry, that is Tina Drexel. Name second name equals name list get entry 2. And so we're seeing the code and then the use of the code there in a short form. So we have a couple of Java class libraries that we'll mention. The first is the interface list. And so the standard package Java util contains an interface list for an ADT list that is similar to the list that our interface describes. One difference between a list in the Java class library and our ADT list is the numbering of the list entries. A list in the Java class library uses the same numbering scheme as a Java array. The first array is at position or index 0. In contrast, we begin our list at position 1. The interface list also declares more methods than our interface does. You'll see a few of those additional methods in Java Interlude 4. The following methods headers from the interface list are for a selection of methods that are similar to the ones you have seen in this chapter. We have highlighted where their they differ from our methods. Once again, T is a generic type of the entry in the list, public. And then we have the list that you can see here in the chart. The other Java class library element we'll talk about is the class ArrayList. So this class called ArrayList implements the interface Java util list that we just discussed. The class also is in the package Java util. So two of the constructors available for ArrayList are public ArrayList, create an empty list and initial capacity of 10. The list increases its capacity as needed by the unspecified amount. So it gives you an example. We have public ArrayList in capacity, in initial capacity. So this creates an empty list with a specified initial capacity. The list increases its capacity as a need by an unspecified amount. And so then below that, we have the Java class utility vector, which we described in chapter 6. It's similar to ArrayList. Both classes implement the same interfaces, Java util list as well as others. Even so, vector contains a few more methods than ArrayList. We'll ignore these extra methods as they are mostly redundant. You can use either ArrayList or vector as the implementation of the interface list. For example, you could write either of the following statements to define a list of strings. So there's a couple possibilities. I won't go over that. So our list interface is somewhat similar than Java's list. Since it has fewer methods, we can retain the simplicity of our interface and still make use of an existing class by using either ArrayList or vector in an implementation of list interface. The approach is like the one we used in listing 6.3 in chapter 6 to implement the ADT stack. And so that's what we wanted to cover for this introduction to list, and that will be it for this lecture. Thank you very much.